This very goofy example shows you two different variables, but this week we are focusing on exploring usually just a single variable. So let me use this other example. These graphics were designed by a former student of mine from the University of Miami called Nick Aguirre. He's currently teaching web design and also visualization at the University of Indiana in Bloomington. And this is part of his thesis project when he was a student, one of my students at the University of Miami. So Nick was interested in exploring the tuition cost of higher education institutions in the United States. So he gathered a huge data set. He divided the data up by in these categories: private for-profit institutions, private non-profit, and then public institutions. And then he explored the shape of the data, the range of the costs, and also the shape of the data. And he did it first using histograms. This is called a histogram in the literature of visualization. Now, what is a histogram? A histogram is similar to a bar graph, but on the x-axis, instead of having a categorical data, you have some sort of continuous variable, right? In this case, you have the tuition costs, right? And here you have ranges from 0 to 10, from 10 to 20. Actually, the ranges are smaller. It's only that we don't have tick marks for each one of them. So it's probably from 0 to 1, from 1 to 2, 3, 4, 5, up to 10, and then 11, 12, etc., etc., etc. So on the x-axis, we put the tuition costs. And then the y-axis is the number of cases, the counts, in this case, the number of schools, the number of universities, right? So the higher the bar, right, the higher the number of schools that charge this amount over here, which is probably $12,000 a year, $13,000 a year. So what can we discover thanks to these histograms over here? Well, first of all, we can discover that public higher education institutions tend to have lower costs in general than private for-profits. That's the first thing that we can discover. The second thing is that we can also explore the relative concentration or density of the data versus the relative dispersion of the data. Public institutions tend to be clustered. Probably the mean value is around here, and the median, the averages are around this area over here. And all the cases, most schools are clustered around that average, right? But if you take a look at private nonprofit, the median value of private nonprofit institutions is probably around here. And the data is much more dispersed, right? You have lower cost, relatively low cost institutions over here, and high cost institutions over here. Actually, the most expensive institutions in the United States are private nonprofit institutions, okay? And then private for-profits, the shape of the data has a similar shape to the public institutions. Most of the institutions are around the median value, which is probably around here, but the data is more dispersed than public institutions. You also have low cost and relatively high cost institutions over here. So the histogram lets you see density versus dispersion. Those things are equally important. The range of the data versus how close most of the cases are to the average, to the averages that you can calculate. Remember that there are 3 different averages that you can calculate. There are more, but the most common ones are the median, the mean, and the mode. There are others, but those are the main ones. Now, this other chart that you have over here is another way of visualizing the relative density or dispersion of the data. It's called a strip plot. The difference between a strip plot and a histogram is that in a histogram, the height of the bar represents the number of cases in this particular cost bracket, right? The cost bracket is put on the x-axis. Well, in this case, in the strip plot, the x-axis is also the cost of those institutions, but then each one of the institutions is represented with a little dot, okay? And then by the sheer concentration of the dots or dispersion of the dots, you can also visualize the dispersion or the concentration of those institutions around several areas of the x-axis. That's another way of exploring density versus or concentration versus dispersion. And another way of visualizing a distribution, dispersion versus concentration, is the box plot. A box plot is what you can see over here, this little box that has been overlaid over the strip plot. The next slide shows how to read a box plot All right, so this is sort of a cheat sheet of how to read a box plot, which sometimes is also called a box and whisker plot, because sometimes it also includes a whisker. I'm not going to spend a lot of time explaining what that whisker is, but it's just a means of visualizing the outliers, the values that depart a lot from the median value over here. Okay, so use this slide as a cheat sheet to understand how to read a box plot. But it's basically read this way. On a box plot, the first thing that you have is the median value, which is this line over here. Now, the median value of a distribution is that value that splits your data up into two halves on 50 and 50%. So that means that half of your values are below the median value and half of your values are above the median value. And then the other boundaries that you have over here, this other boundary and this other boundary, they are called the quartiles. Well, actually the median is also a quartile. So let's say this line, and that line over there are the quartiles of the distribution. This is another way of representing distribution and dispersion. Now, what are the quartiles? The quartiles are those values in your distribution, in this case the distribution of private and non-profit tuition costs, those values that divide your distribution up into 4 equally sized areas or groups. So here you have the bottom 25% of the schools in terms of private non-profit schools in terms of costs, the middle 25%, the middle upper 25%, and the upper 25%. So these are the quartile groups. We have 4 quartile groups, and the boundaries between those groups are the quartiles of the distribution. So there are 3 quartiles. The first quartile, the second quartile, which is the median value, and then the third quartile. Okay, so this is just another way of showing the distribution. Now, why am I showing you this example? Just to illustrate, and this is a theme that we will go back to over and over and over again during this MOOC, a single visualization usually will not yield all the possible insights that you need from your data. This applies to just exploring something as simple as the distribution of your data. Sometimes if you only use histograms, you will not perceive important features of your data. So I usually recommend to represent your data in multiple ways. In this case, the histogram, the strip plot, and then the box plot, because each one of them may show you something interesting in your data. Again, sometimes a single visualization will not show you everything that you need to learn from your data set. Well, I hope that this short lecture got you inspired for the week. Now please proceed to Heather's videos, and then let's get the discussion started.